Hello and welcome to today's lesson on inequalities. Please make sure that you have somewhere to take notes because I will be looking at those in order to give you the homework assignment today. So once again, please make sure you are taking notes as you are working on this lesson today. Our objective today is that mathematicians can write, graph, and identify solutions of inequalities. And before we get started, we want to make sure we remember what an inequality is. An inequality is a mathematical sentence that uses an inequality symbol to compare the values of two expressions. So hopefully you remember your inequality symbols: greater than, less than, greater than or equal to, and less than or equal to. Those are your four main inequality symbols. We can also use a number line to visually represent the values that satisfy an inequality, and you will see that later in the lesson here today. So let's go ahead and get started. What inequality represents the verbal expression? So we are just going to be writing an inequality. All real numbers x less than or equal to 7. So all real numbers, and then it refers to my variable right there. So I've got my x less than or equal to. So I am going to have x, or all real numbers, less than or equal to -7. In my second one here, 6 less than a number k is greater than 13. Now as we look at this, I see a lot of times students look at a question like this and are not sure which is supposed to mean the inequality symbol, because we are going to just be having one inequality symbol right now. And when I read that first half, 6 less than a number k, that makes me think that it is probably actually k minus 6. 6 less than a number k is greater than 13. So I end up with k minus 6 is greater than 13. Alright, please pause the video and take a look at these. When you think you have an answer, please resume to check your work. Alright, welcome back. The first one, all real numbers p greater than or equal to 1.5. So p, all real numbers, greater than or equal to 1.5. The sum of t and 7, sum means addition, so t plus 7 is less than -3. So as we continue on here, some vocabulary that we just need to be aware of. A solution of an inequality is any number that makes the inequality true. So for the solutions of the inequality, x is less than 5. All real numbers x that are less than 5, so any number less than 5 can fit as a solution in this inequality. So you will notice that sometimes we will have more than one possible answer. Like this, any number that is less than 5 we could substitute in for x and have a true math statement. You can evaluate an expression to determine whether the value is a solution of an inequality. So I can plug numbers in for x and decide, is it a solution or not? So I plug in a number less than 5, 4. Is 4 less than 5? Yes, it is. But if I would pick a number 7 and plug it in for x, 7 is not less than 5, so it does not a solution to that inequality. So how can we take that thinking and apply it when we have something like this? Identifying the solutions to the inequality. Is the number, down here, -3, a solution to the inequality 2x plus 1 is greater than -3? So what I need to do is plug that -3 in for x. 2 -3 plus 1 is greater than -3, and I need to solve. 2 times -3 is -6 plus 1 greater than -3. And -6 plus 1 is -5 is greater than -3. So is this a true math statement? Well, it's not. -5 is actually smaller than -3, so this is not a solution. Okay? But now I also need to do that with my negative 1 here. So I'm going to need to erase. And do the same thing again with my negative 1. 2 times negative 1 plus 1 is greater than negative 3. Well, 2 times negative 1 is negative 2. Plus 1 is negative 1 is greater than negative 3. And this is a true math statement. Negative 1 is greater than negative 3. So negative 1 is a solution to this inequality. So please take a moment, pause your video, and see which of these numbers are solutions to this inequality. When you are ready to check your answers, please resume your video. Alright, welcome back. So you should have plugged in all 4 of those numbers in for y. So for example, when you plug in negative 1, 13 minus 7 times negative 1 is less than or equal to 6. 13, negative 7 times negative 1 is positive 7. 13 plus 7 is 20, and 20 is not less than or equal to 6. So negative 1 is not a solution. When you plug in the number 0, you end up with 13 is less than or equal to 6, so this is also not a solution. When you plug in the number 1, you should end up with 6 is less than or equal to 6, and because of the or equal to line, 6 is equal to 6, so that is a solution. And the number 3, when you plug that in, you get negative 8 is less than or equal to 6, and that is also a solution. So negative 1 and 0 are not, 1 and 3 are. So let's continue on here. Graphing an inequality. We a lot of times will see inequalities graphed to help us indicate all of the solutions that are possible in an inequality. So as you look at this here, n, excuse me, n, or all numbers, less than 1. What that tells me is that any number less than 1 can fit into that inequality and be a solution. So as I look here, I start at the 1, and I'm showing that all of the numbers smaller than 1 are solutions. In the second one, you see A, or all numbers greater than or equal to 0, so this starts at 0 and shows all of the numbers that are greater than 0 with the line going to the right that are solutions. Now, you'll also notice between the first and the second one, the first one has an open circle, and the second one has a closed circle. That is a very important difference to make sure that you do not forget. An open circle indicates that that number itself does not fit as a solution. So for example, if I were to put the number 1 in for this first inequality, 1 is not less than 1, so the number 1 cannot be a solution. However, anything smaller than 1, so 9/10 is slightly smaller than 1, and that could fit as a solution. So while we don't typically use decimals or fractions at this point, at least in our inequalities, we do need to represent that anything less than 1 is a solution. Whereas in the second one, when we have a closed circle, what that indicates is that that value can be a solution. So I can plug a 0 in for A, and 0 is greater than or equal to 0. It is equal, so that is a solution. Okay, so in the third one here, F are all numbers greater than negative 3, so we have an open circle because negative 3 does not work as a solution, but we are demonstrating with our arrow and our line that any number larger than negative 3 can fit. In the last one, negative 2 is greater than or equal to x, so we have a closed circle because it does have the or equal to symbol, and pointing to the left indicating the numbers less than negative 2. Now, one way to verify that you have your arrow pointing in the correct direction, and this will be very valuable as we start to solve our inequalities, is checking your answer. The way to check your answer is pick a number from anywhere on your line and plug it in for the variable. So, in the first one, n are all numbers less than 1. Let's plug in -2, and does that make it a true math statement? -2 is less than 1. That is a true math statement, so my arrow is pointing in the correct direction. A are all numbers greater than or equal to 0. I can plug in 3 and show that that is a true math statement. All numbers, or F, greater than -3. Plug in 4, and it does show that it is a true math statement. -2 is greater than or equal to x. Plug in -4. Is -2 greater than -4? Yes. Okay? So as we are doing this, you have multiple ways of checking your work here. A way that it could be wrong, what if I plug in a 1 for x down here? -2 is greater than or equal to 1. -2 is not greater than 1, and it is not equal to 1. So therefore, that is not the way that my line should be facing. All right, please take a moment and graph this inequality on your own and press play when you are ready to check your work. All right, welcome back. You'll notice I am just numbering my number line here. What is the graph of 2 is greater than or equal to a? Well, I know that I'm going to start at the number 2, and I also notice that because I have the or equal to line, that I'm going to have a closed circle, or as best as I can. 2 is greater than or equal to a. So when I look at that math statement, I'm thinking that my arrow needs to be pointing to the left to show the numbers that are smaller than 2. But once again, I am going to double check myself, and I'm going to do that by trying to plug in a value for a. Is 2 greater than or equal to 0? Yes, 2 is greater than 0, so that seems to be a true math statement. I could double check myself by putting in a number from over here. What about if I plug in a number from the right side of my point? Is 2 greater than or equal to 4? Well, no, 2 is not greater than or equal to 4, so this is not the correct direction for my line, and so I have my graph in the right direction. Please take a moment and create a graph for each of these 3 problems. When you are ready to check your answer, please resume your video. All right, welcome back. Let's go ahead and check our work here. So all numbers, or x is greater than -4. I have I have a greater than symbol, not the greater than or equal to, so I'm going to start with an open circle, and it says all the numbers that are greater than -4. So I believe that my arrow is going to be pointing to the right. And once again, I can even check. Is 1 greater than -4? Yes, it is. Okay. I'm going to switch colors here to blue to color code my answers here. C is less than 0. I do not have the or equal to symbol, so I'm just going to have an open circle on my 0. And it says C are all the numbers less than 0. So this arrow, I believe, is going to be pointing to the left. And once again, I can double check, plugging in a number from that line. -2 is less than 0. That is a true math statement, so I think I'm on the right track. And then last but not least, 3 is less than or equal to n. So I see that or equal to symbol, so I'm going to have a closed circle on the 3. And I believe that it is going to be pointing to the right, but once again, I'm going to check myself, plugging in the number 4. Is 3 less than or equal to 4? Yes, it is. So we need to also be able to go in the opposite direction, looking at graphs and writing the inequality. In the first one, I see a closed circle, so I already know that I'm going to have something with the or equals to line underneath it. I also notice that my point is starting on the -1. So I'm going to start with my -1. And I look at the line. The line is representing that my values, my variable, is going to be larger than -1. So my variable x is greater than or equal to -1. Once again, I can check myself. Is 2 greater than or equal to -1? Yes, it is. On the second one here, I've got my variable. I see that my circle is on the 4. And I see that my circle is open, so I'm not going to have the or equal to line. And I believe that in this case, it is referring to the numbers that are less than 4. So if I plug something in, does that work? 2 is less than 4, and yes, it does. Go ahead and write your inequalities, and when you are ready, check your work. So what I have here, x are all numbers that are less than -3. So if I put in a -5, is that less than -3? Yes, it is. And the second one, x are all numbers greater than or equal to 0. Plug in a number there, and it does make a true math statement. All right, in a real-world situation here, writing an inequality that describes our real-world situation, and we do need to make sure that we define the variable or state what the letter is going to be standing for. So as I look here, I see a sign that talks about trail rides, and it looks like we're talking about the cost of trail rides. So I'm going to write C equals cost of the ride, and that is going to be part of my inequality. I notice that the ride is starting at $19.99. So when I see the word starting at, that leads me to believe that that is the lowest price that I will pay, and that there is a possibility that I will pay more than that. So I believe that my variable, my end cost, is going to be greater than or possibly equal to $19.99. Please take a moment and write an inequality for this image, and also answer the question, can the speed be all real numbers less than or equal to 8, and explain your thought process there. When you've got the answer to this on your notes, please show me and I will give you your homework assignment.